Hello and welcome back. Today, Tom Crecelius is joining me, and I'm very much looking forward to our conversation about software architecture. Hi, Tom. Thanks for being here.
Hi, thanks. It's my pleasure.
So let's dive right in and discuss why software architecture is so important. So let's imagine you have a business and you want to build a simple e-commerce app, maybe. And, it's not a big deal. You start implementing it. It all works well. So why should you even think about software architecture for such a small use case?
Well, when you decide to start an e-commerce business, then you plan to fulfill some market needs, or otherwise your business idea lacks its foundation, right? So you expect there will be customers who are interested in what you want to offer.
Right. And in case your business idea actually succeeds, you will get more and more customers along the way.
Yes, and growth is an important consideration for a business, and even a small application may need to grow quickly. Without thinking about the right software architecture early on, your application can become messy and inefficient, may reserve more CPU and main memory resources than required.
And that means that you're basically wasting money right there.
Exactly. And then you start implementing more and more workarounds and quick fixes to compensate for these design weaknesses. And over time, this creates technical debt and makes your application hard to scale and maintain. And as a consequence, your application's performance can degrade considerably.
Right. And that's indeed bad because your customers probably will grow frustrated. And in the end, you may even altogether drive them away if it's getting too bad.
Yeah, and in such a worst case, there's no other chance but rebuilding the entire system from scratch again. And when starting with the right software architecture, you can avoid such issues.
Thinking about situations that are a little bit different and where the customer numbers don't really play that big of a role, how does it play into that type of situation?
Well, it's still important to think about the software architecture. It's always required because you want to avoid unwanted surprises and to want to make sure that your application works as efficient as possible and best in all your use cases. So let's consider an application that is processing distributed data for statistical analysis, or an application that is training an AI model. Of course, you want that your application works as efficient as possible and as reliable as it needs to be. And ideally, it should also only consume as many resources as it really needs to fulfill its task. And the task itself should be completed successfully within a predictable amount of time, maybe even in the presence of failures or unforeseeable issues. So in the end, your application runs for a reason, and potentially business decision depends on its outcome. So it better should work reliably, right? So software architecture is essential in defining what your system can achieve and what guarantees you can expect from.
Yeah, so scalability, performance, and also reliability are huge factors, and they are influenced by your choice in software architecture, obviously. So let's next touch on data integrity and security aspects. Can you comment on those?
Oh yeah, software architecture not only impacts how well your system can handle growth or how efficient it is, data integrity and security aspects are important as well. By the way, both are related to each other because a security breach could also be the reason for corrupt data. But let's consider our e-commerce business example again here. Customer data and payment information must be accurate and secure at all times. Whereas in our statistical analysis example, there may be less strict requirements and eventual data consistency can be enough. But also keep in mind, as said before already, business decision may depend on that data. So in such a case, you still want the data to be correct, but also to be complete. And the right software architecture ensures that all these aspects are covered and fits to the specific needs of your software. And to protect actually both your business and your users.
So next, I would like us to comment briefly on some more practical aspects maybe. So maintenance and deployment play a huge role in real life, right? So what should we keep in mind with respect to these?
Oh software architecture plays indeed here an important role as well, because the complexity of deployment and maintenance tasks can vary a lot with each architecture. And sometimes when favoring low complexity for deployments, then the complexity for maintenance arises and vice versa. So for instance, a single large service can initially be easy to deploy, but may become more complex to maintain over time, because even small changes, minor changes, always affect the entire system. So software changes needs to be carefully coordinated within a development team. And in contrast, a small and loosely coupled service, or many loosely coupled services, they can be changed and deployed independently, and that's reducing risks and increasing efficiency. Bootstrapping the entire system, however, is more complex because you have to configure all those services individually while keeping the dependencies between those services in mind. So when planning software architecture, you really have to think about each aspect of your software's lifetime, and that includes deployment and maintenance too.
Yeah, and just differs where your complexity will lie and what is best for your personal situation. So you briefly mentioned the development team before, and I would like us to talk about the connection of the development team and the choice in software architecture a little bit.
Actually, it's indeed important to think about the developers who have to implement a chosen architecture. Here, the team size and the team's experience are absolutely important factors. If the team lacks a specific expertise in implementing particular architecture, for example, they never came in touch with cloud-native architecture and Kubernetes, then the learning curve can slow down the development, and of course then has also an effect on delaying a potential market launch. So that means the right software architecture must match the skills of your development team when it comes to time to market.
Yeah. People may wonder, why can they not simply pick some existing basic software pattern and use that to begin with, and simply adjust later when they figure out that it does maybe not match the needs that they encounter and the ways in which it doesn't fit? What's wrong with that approach, maybe?
That sounds practical, but software architecture often tackles different, even contradictory objectives. And for example, like responding to a single request as quick as possible, and that may require very fast in-process communications and in-memory data structures. But others try to increase the throughput, for example, and that is maximizing the number of requests a system can handle within a given period of time, which then again requires more flexible and scalable solutions with decoupled services, for example. And then others again try to reduce main memory efforts and so on.
And if you start out with something that is not really a great fit for you, then potentially you'll have to overhaul your entire system, and that will be time consuming and very costly, right?
Exactly. And apropos expensive, you want to be cost effective. It's never a clever idea to waste money for a business. And choosing an architecture that works for your use case but comes with excessive costs, maybe due to high hardware or maintenance costs or complex development efforts, that's not necessarily the best fitting architecture, and definitely not if it causes higher costs than needed.
Right. So I think we have established that it's a good idea to try and pick a suitable architecture early on that fits your use case and your business goals, and that will enable you to operate in a cost-efficient manner, right? So it is important to early on pick an architecture that aligns with your business use case and that is cost-effective for your situation. So how can companies go about this? Is there some template that they can follow?
Unfortunately, there's no simple template that you can apply to any business case and then spits out the ultimate plan leading you to success. It would be really nice if it works like that, but unfortunately it doesn't.
Okay. However, there must be some key first steps that companies can think about first.
There are very important steps to take before you even can think about software architecture. And these steps are really challenging. First, get and understand your business cases with all its objectives and requirements. The functional and non-functional requirements. And don't forget about the hardware and technology constraints under which these requirements have to be met. Second, ensure that all decision makers understand them in the same way. And then next, discuss your options.
And when discussing your options, what are important questions to address?
Well, which proved and tested software architecture patterns exists and fit to your objectives? What are their advantages and disadvantages specific to your use case? What are their costs, again, specific to your use cases? And with costs, I mean costs in terms of money, but also in terms of time. And don't forget about the maintenance and deployments and operational costs and costs for required infrastructure and so on. And then keep in mind that requirements can change over time. So how flexible is a given architecture and how well can it be adapted to your current needs and potential future needs? So you really need to have a glance into the crystal ball and think about future scenarios when thinking about software architecture.
Yeah. So what would you say is the main reason that makes it hard to pick the right software architecture?
Well, the reasons are actually not the functional requirements, because for those there's already a solution since 1936. That's the year when the Turing machine was invented, and it can solve arbitrary computational problems. But, well, that doesn't help you with your software architecture, as a solution must work practically and not only theoretically. That means, the non-functional requirements, unfortunately, are the reasons that make designing software architecture hard.
Right. So we're already nearing the end. And before we conclude, could you describe how CID as a company is involved in software architecture?
Well, we at CID have been working on software architecture topics for a long while already, something like 20 plus years or so. And we have gone all the way from a monolith to cloud-native architecture, and we tackled and managed many challenges on that way. So we gathered valuable insights into designing software architecture, but also in utilizing and operating an own private cloud at large scale. CID has therefore gained a great deal of experience through this many years of involvement in software architecture, and actually is well equipped to advise on a variety of architecture scenarios. So yes, that's what we do, and our customers benefit from our experiences.
Thank you, Tom, for this nice conversation.
You're welcome.
And thank you for watching. Make sure also to stop by the CID website, where Tom has a blog post ready for you that gives more insights and details about the topic of software architecture. Thanks again. Goodbye.